Late model JKUR with a 6.2 L86 Gen 5 GM engine and 8-speed transmission. Like it or not, this is the way we're going. Engines are getting more complex to get better efficiency and power. The Gen 5 engines are a perfect example of that. This engine has a lot of power, but it's also very docile. The way we were doing things with the earlier Gen 3 and Gen 4 motors is going to change. I like doing swaps with the Gen 4 engines, but we've got to move forward. Starting in 15, most of the GM engines were Generation 5. They added direct injection, continuous variable valve timing, high compression, enhanced air fuel management, all in an effort to get better economy and performance. If you have a late model JK, to stay legal, you're going to have to step up to one of these Gen 5 motors. This L86 is really smooth. This Jeep has all of our latest easy components, including the no weld, no fabrication engine mount, the factory engine harness. This does not have our billet accessory drive because we're running the Gen 5 accessory drive, which works really well. We do add a power steering pump because the Gen 5 engines don't have a power steering pump. They use an electric steering setup on the OE vehicles. Bottom line is this motor runs really good. Has a lot of technology in it. We've now done swaps with the Gen 5 5.3 L83, the Gen 5 6.2 L86, and the LT1. We're looking forward to doing the LT4 and possibly the new LT5, including the 10-speed transmission. The way we implement our swap, keeping the GM network, makes it future-proof, and it lends itself well. Let me explain. If you were to use, let's say, a hot rod harness to put a Gen 4 or even a Gen 5 into your vehicle, there's emissions reasons, and you're basically building a harness from scratch that you have to depend on, and if that harness ever goes bad, you're going to have a hard time sourcing one. Or even if you could source it, it's just not going to be as available if you used a factory harness. As GM comes out with new engines, let's say the new LT4, the new LT5, and who knows what else they're going to come out with. Essentially, all we have to do is install it in the chassis and then use our little CAN interface to make the two communicate. So we're not slaving ourselves to a specific operating system. We're not hybriding, meaning running the GM engine within a Chrysler operating system. We're running GM transmission, GM engine, which means we have GM tap shift, GM cruise control, GM air conditioning control. It's not hybrid and patched together, and it's not using aftermarket components. It's using OE components. We're running smart charging on this Jeep. One of the benefits of our swap over some of the others is that you can use OE components, and that includes not only the engine, but the electronics, the computers, and even a lot of the hardware. The engine mount, the tranny mount are all available at your local dealership. Striving to not use any aftermarket components. Now, of course, there's some things that we do have to supply, like our frame brackets, our billet accessory drive, but we keep it to a minimum. We even use a lot of the original lines and hoses, like the power steering hoses are all OE. Even on this Gen 5, we're using the factory power steering pump and hoses. This makes it a lot easier for you to source these parts at your local dealership, whether you're in Las Vegas or Abu Dhabi. When it comes to diagnostics, you can plug in a GM scanner into the engine performance side of this JK, and you'll get virtually all the same data that you would get with the OE vehicle. I think this engine came out of a 16 Denali. So all the bay tests, evap, misfire, fuel injector, AFM, the 4-cylinder mode lifters, CVVT, it can all be tested. The trouble codes are run exactly the same way as the factory vehicle. The wire colors, it's a factory harness. And most of you know that we have adapted to the GM harness rather than adapt it to us. So the power distribution center plugs in, the chassis connector, the interior connector just plug in like it would in a factory vehicle. Therefore, you could replace the harness with a replacement harness right from GM. Implementing the build this way has a lot of advantages. It means that we can output a kit in a box. You don't have to buy an engine from us that's been modified. There's just a whole host of reasons why you want to keep things as stock as possible. And just because it's stock doesn't mean it doesn't perform well. This engine has well over 400 horsepower, and it has most of its torques available just off idle. The torque curve on this engine is very impressive. This truck L86 will take most of the last generation V8s, including the 6.2 truck motors, the 6.2 LS3, the 6.4 Hemi. It's a very powerful engine. Right off idle, you have almost 400 foot-pounds of torque available to you. I believe 350 at 1,500 RPM. That's just off idle, which means if you get 40-inch tires and a 6,000-pound JK, it's going to launch like a go-kart, and that's exactly what this one feels like. This does have the 8-speed in it, and the 8-speed does have a 4.6 low versus the 6-speed 4-to-1 low. I still like the 6L80. It's an excellent transmission, and 4-to-1 low is more than enough for most JKs. But if you are going to run, let's say, 40s with 488s or 513s, and you have a really heavy JK, that little bit more low ratio can help out. It allows you to run a taller gear and still get good bottom end performance. And when you run the taller gear, you're going to end up getting better economy on the top. So the 8-speed does diversify the gearing, and it does give you a little more grunt on the bottom and a little bit more top end. The 8-speed is a 0.6 OD, where the 6-speed is a 0.66 overdrive. But compared to Chrysler's 0.8, still have a big advantage there. You can get the 5.3 L83 and the 6.2 L86 in either the 6-speed or the 8-speed transmission. I believe the LT1 is only available with the 8-speed. Anyway, I look at it, it's a huge step up from a V6, and when I drive the GM transmissions compared to the Chrysler transmissions, they just feel better to me. They shift better, they feel smoother, there doesn't seem to be a gap in gearing. I really like the way the GM transmissions work. The 8-speed, unlike the 6-speed, did go back to a traditional valve body. It's not clutch-to-clutch like the 6L80. 6L80 is really a great transmission as far as how fast it can shift and its efficiency. This L86 has absolutely docile drivability. It doesn't exhibit any of the characteristics of the high-performance Gen 4, Gen 3 engines. If you look at the 480 horse LS3 or the 525 horse LS3 based engines, they've got a lot of rump to them. This engine, on the other hand, is as docile as your V6, but it is a monster. About 1500 RPM, you have over 350 torques available to you. I believe it's 350. It might be a little more or less. And it has well over 400 foot-pound of torque, and it carries that all through the power band from just off idle into the 4,000 or 5,000 RPM range, which is amazing. If you look at a supercharger or a turbocharger or even the high horse Hemis and LS3s, their torque builds up and it peaks 3,000, 4,000, 5,000 RPM. This engine's putting that same amount of torque out just off idle. What that means is this heavy JK with an 8-speed transmission moves completely effortless. With the continuous variable valve timing, high compression, I believe this engine is 11.5 to 1, and direct injection. We all know what high compression does, and I think we all know what direct injection does. Direct injection basically puts the fuel directly in the combustion chamber, so it's not being shot in behind the intake valve, and that does a lot of things. Adds to combustion efficiency so that you can run the higher compression with the lower grade fuels. Direct injection was challenging. Back in the 1970s, Ford actually had experimented with direct injection, and the Europeans were experimenting with direct injection. They had issues with the metallurgy and the nozzles holding up and plugging up and carbon building up behind the valves, but that has pretty much been sorted. In today's world, direct injection motors are everywhere, and there are definitely advantages to it. The computing power required to drive direct injection and these Gen 5 motors obviously is pretty intense. We've got continuous variable valve timing, so the cam is constantly phasing, controlling cylinder pressure. The cam not only phases for best economy and performance, but for emissions too. GM has some patented technology on how the cam phases in relation to the intake valve so that it doesn't build up carbon, and at the same time they're also controlling NOx, that's nitrides of oxygen, through cam phasing. And even though these engines don't have an EGR valve, that's an exhaust gas recirculation valve, exhaust gas recirculation is essentially designed to reduce NOx. How does it do it? It reduces combustion chamber temperature. How does it do that? Well, it takes inert gas, or mostly inert gas, from the exhaust, which has already been burned, and it puts it back into the combustion chamber. Exhaust gas recirculation. And what that does is it takes the volatile mixture that's in the chamber and it dilutes it. So that brings the combustion chamber temperature down. The nitrogen and oxygen atoms don't melt together, and you don't have NOx emissions. You're breathing about 79% nitrogen and about 20-21% oxygen. By using the cam and phasing it intelligently, GM has achieved a lot of things. Not only more power by using one cam profile, but they've reduced NOx emissions. They actually include a NOx or an EGR monitor, even though these engines don't have an EGR valve, because essentially the cam phasing does a similar operation. They've allowed us to run higher compression. Obviously the combustion efficiency has improved. When you combine that with continuous variable valve timing, we're refining what VVT was in the Gen 4 engines, and there was no VVT in the Gen 3 engines. Continuous variable valve timing is an enhancement on variable valve timing. Essentially, with variable valve timing, you're keeping the same cam profile, but you're retarding and advancing the cam based on the conditions. So if you're at an idle, you want to advance the cam for more cylinder pressure. When you rev it up, you want to retard the cam. And that's what VVT does. The Gen 3 motors didn't have VVT. The Gen 4 motors did, but they were discrete. And what that means is the cam was either parked or open. So when you're at low RPM, the cam is going to be in one position, and when you're at higher RPM under a load, it's going to phase into another position. With continuous VVT, we can put the cam wherever we want it, whenever we want. And the benefit to that is, let's say you're going down the road and you want to pass a car and you throttle it. Well, in the old days with the Gen 3 or Gen 4 motor, the odds are the transmission was in a downshift, put the engine in its power band, and then after you passed the vehicle, it would then upshift again. With CVVT, you're going down the road, you throttle it, and you can actually feel the cam phase. The transmission does not shift. The cam phases, you get that extra burst of cylinder pressure and power, you pass the vehicle, and you never shift it. So there is some advantage to it. Is it huge? No. But when you add up the incremental improvements with direct injection, continuous variable valve timing, and now the enhanced air-fuel management, we're waiting for these engines to be sorted by the aftermarket. You know that there's going to be blowers and camshafts and all that available, but these engines are capable of putting out so much torque at such low RPM that we're actually restricting them from breaking parts. If you were to take this L86 and unleash it, all the torque that it has, there's a really good chance you're going to start breaking driveline parts. Because when you put out that much torque at such a low RPM, it's a lot of stress on the driveline components. We've done L83s, L86s, and even LT1s over the last year. So let's go over this build. This is going to represent pretty much the build of the future. What you see out there right now with the Gen 4 motors will eventually either go away, or guys are going to want to move on to the newer technology. Not that the Gen 4 and the Gen 3 motors aren't good, but the reality is engine technology has progressed. So this Jeep is an 8-speed. GM reverted back to a traditional valve body over the 6L80. I'm not exactly sure why. I think the dual clutch 6L80 is a great transmission. This 8-speed feels good too. It's very hard to tell the difference, even though they're two very different technology. So we have a L86 8-speed direct injected engine in this JK. It was installed with no fabrication. What that means is there was no cutting, welding, or grinding in the entire swap. The engine mounts just bolted in. Transmission mount just bolted in. We didn't have to cut or drill the firewall. We didn't have to relocate the steering shaft. We didn't have to relocate the battery. It is a larger engine than the Gen 4s, but when positioned properly, you're fine. The easy engine mount do allow adjustment in all 3 axes. If you're tied up against the firewall or the passenger side, you can fine-tune it with the easy engine mounts. This vehicle is running the stock harness and stock E92 computer, as well as a stock external TCM. The 8 speeds went back to an external transmission control module. The 6L80s had it built inside. I kind of like the internal TCMs, but it's not a big deal. The earlier Gen 4 engines were running an external T42 transmission control module when running non-CAN bus driven transmissions. With our easy harness, this depends on the configuration of what engine you have, whether it's a Gen 4, Gen 5, 5362. Our goal was to make it plug and play and use available parts. It is much easier to build custom parts like harnesses, but what we wanted to do is allow you to have access to parts anywhere in the world through your dealership. So by using a factory harness that plugs into our power distribution center, plugs into our interior connector, plugs into our chassis connector beams, this is a factory production piece that you can get through your local dealership. And the flip side of that is it has all the factory quality testing. If you ever did have to have diagnosis done in your Jeep, any tech that knows GM could hook up factory tools running factory troubleshooting charts and diagnose your Jeep. And if a part needed to be replaced, like a computer or a harness, you're not coming back to us. You can have it done at your local level. The Gen 5 engines do not run power steering pumps as mentioned, so we make our own power steering pump for the Gen 5s. But other than that, we're using the Gen 5 alternator and air conditioning compressor. The computer is controlling the air compressor and alternator for smart charging, as well as fan control. This has a variable speed fan, 19-inch blade, Camaro SS fan, very powerful fan. It's controlling it for condenser pressure, We don't run the fan on high. Now, I will say that I do think there is some advantage to running the fan at a low speed to evacuate hot air out of the engine compartment. We've been doing that for years, and on the variable speed fan, being sealed, outrunner, brushless, ball bearing, you can pretty much do that without a lot of energy. Guys running fans at full speed, it can be really annoying. I like to see a fan run at low speed for a couple of reasons. It keeps the coolant temperature more constant instead of seeing that cycle up and down with a discrete fan. Two, it keeps the hot air out of the engine compartment, and it moves air through the engine compartment so that you don't get heat soak. You don't get 300-degree underhood temps when it's hot outside. And then when the fan does need to wind up, it ramps up for condenser pressure, trans temperature, whatever. So I do like to do that, and we can program it in if you choose. But if you don't, we can make the fan shut off as intended. We can support the Pentastar fan, and we can support the Camaro fan. If you do have a Gen 5 motor and you want to run a Pentastar fan, there are some restrictions, so give us a call on that. Because the way Chrysler sets up their programming in the fan module, we do have to set it up a little bit differently on the Gen 5 motors than we would with the earlier Gen 4 motors. So essentially what we have here is a Jeep with a GM powertrain that is all GM. You have a GM engine, GM transmission, GM harness, GM controls, GM software, GM computers. We went through this back in the Gen 3 days. We used to use Gen 3 swaps, but in 07 we pioneered the Gen 4 swap just like we pioneered the Gen 5 swap. And to my knowledge, no one has done, at least in the Jeep community, a Gen 5 swap to the level we've done it. We're not just installing a GM performant Gen 5 LT engine, we're installing a complete network. We're installing the 8-speed transmission and all the monitoring and emissions, and you know how that goes. So no one's done it to this degree that I know of, and we've been doing this for over a year. And when these Gen 5 motors are set up right and geared right, they're just a dream to drive. And I think there's a lot more to come. I've been told by some GM guys up in Michigan that these engines are held